where the heat has nowhere to go. By 2350, nobody talked about energy shortages anymore. That battle had been fought and won decades ago, not through a miracle technology, but through accumulation. Better storage, better distribution, fusion-adjacent systems that never quite crossed into true abundance but came close enough that no city went dark unless someone wanted it to. What people did not talk about was heat. The settlement of Kepri orbital hung above Earth in a slow equatorial drift, a layered cylinder of habitation, fabrication, and data infrastructure. It was not large by contemporary standards, but it was dense. Designed during the unification push of the late 23rd century, Kepri embodied the thinking of its time: redundancy everywhere, autonomy by necessity, and thermal margins calculated aggressively to minimize mass. For 20 years, those margins had held. Until they didn't. Mara Chen watched the heat maps bloom across her console like bruises. Red zones spread through sections that should have been cool, stable, boring. Radiator arrays were reporting normal function. Power draw was within expected variance. Life support was green across the board. And yet the temperature climbed. "Confirm sensor integrity," she said. Her voice was calm, professional. It had to be. Kepri housed over 40,000 people, most of them contract workers and their families. Panic was inefficient, and inefficiency was lethal in orbit. "Confirmed," the system replied. "Independent sensor nets agree with intolerance." Mara leaned back and exhaled slowly. The problem was not failure. It was success. Kepri had grown. Not in population, which remained capped by design, but in activity. Fabrication cycles had intensified as orbital manufacturing picked up the slack from increasingly strained Earth-based supply chains. Data processing loads had surged as Earth's fragmented political blocs leaned harder on orbital infrastructure they trusted more than each other. All of it generated waste heat. On Earth, heat dissipated into air and ocean. In orbit, it had nowhere to go except outward, radiated away photon by photon. Kepri's radiators were efficient, state-of-the-art, and insufficient. The math had always said they would be. The original designers knew this moment would come, but the solution had been deferred. More radiators meant more mass. More mass meant higher launch costs, more political negotiation, more oversight. So the system had been designed to ride the edge, with the assumption that when the time came, upgrades would follow. The time had come. The upgrades had not. Mara pulled up the governance overlay. Kepri existed in a legal gray zone, like most semi-permanent orbital habitats. Nominally under the authority of the Multinational Space Authority, functionally operated by a consortium of corporations, labor unions, and legacy national stakeholders. Everyone owned a piece. No one owned the problem. She initiated a priority conference. Faces appeared, arranged by affiliation rather than hierarchy. Corporate operations, labor representatives, Earth-based regulators, and one observer from the Unification Council, present but pointedly silent. "We have a thermal runaway developing," Mara began. "Not catastrophic yet. But if fabrication output continues at current levels, we will exceed safe operating temperatures in 48 hours. "And your recommendation?" asked a corporate director, already frowning. "Reduce industrial throughput by 30% immediately. Begin staged installation of additional radiator mass within the quarter." The reaction was predictable. A labor rep objected to reduced shifts. Corporate voices warned of contract penalties. Earth regulators raised concerns about orbital debris risk from new construction. The observer from the council continued to say nothing. Mara let the arguments play out for exactly 6 minutes. Then she cut the feed. She hated doing that. It violated protocol. It would have consequences. But he did not negotiate. She issued the reduction order unilaterally. Within an hour, productivity dropped. Within 6, temperature curves stabilized. The immediate crisis passed. The political one did not. By the next cycle, Earth-based media had picked up the story. Not the technical details. The narrative. Orbital elites throttling production without democratic oversight. Workers idled while Earth faced shortages. A station administrator overstepping authority. Mara was summoned to a remote hearing 3 days later. "You acted outside your mandate," the council representative said, now very much not silent. "I acted within physics," Mara replied. The room did not appreciate the distinction. Sanctions followed. Not against her personally, but against Khepri. Reduced autonomy. Mandatory oversight approvals for future infrastructure changes. A review committee to evaluate the necessity of additional radiators. The committee would take months. During that time, Khepri operated at reduced capacity, its margins thin but stable. Workers grew resentful. Corporate partners quietly rerouted contracts to other platforms. Earth-based factions cited the incident as proof that orbital infrastructure needed tighter control. The irony was bitter. Khepri had prevented a failure by acting decisively. The consequence was loss of trust. Mara resigned 6 weeks later. Her replacement was more cautious. Every adjustment went through channels. Every change waited for approval. Heat continued to rise, slower now, but inexorable. Across orbit, other habitats watched and learned the wrong lesson. They did not expand their radiators. They reduced transparency. By the end of the year, the quiet problem of heat had become something else entirely, a symbol. Proof that even in a world powered by near limitless energy, scarcity still existed. It had just changed form.